Hello and welcome to another episode of AI Daily. I'm your host, Connor, joined once again by Ethan and Farb. Today we have another three great stories, starting with Meta's OpenCatalyst, and then Google DeepMind's R2 speaking robot, and then some pretty interesting new adversarial prompts. So first up, we have Meta's OpenCatalyst, where Meta and Carnegie Mellon University made a new model that can simulate over 100 million catalyst combinations. So it can basically simulate any combination of two types of catalyst materials and find that kind of output that traditionally was not possible to simulate in a way that was fast or quick or easy. This is very similar to something like AlphaFold that we saw from Google that predicts protein structures, but this is now for predicting chemical catalyst reactions. So very applicable to renewable energy and really any kind of chemical processes. Ethan, what do you think about this?
It's amazing. I think you nailed it in the comparison to AlphaFold. Everything is upstream of materials, right? Every single innovation we have comes from a new material. And it's right now, a lot of it is playing, cated game of roulette in which you're trying to guess, what catalyst and what combinations of materials will create what we need. So these types of simulations, which were just not possible before AI, simulating the exact kind of reactivity between everything going on is really just not possible before some of these new tools that are out. So being able to simulate all these things, having the tools available to researchers, I think we're at a renaissance period of genomics, of material science, and these are at the groundbreaking fold of them. So of course I have not got to try it or anything of the sorts, but it looks absolutely amazing from what they've demoed, and I think a lot of people are excited for it.
Farb, we talked about LK99 a couple of days ago. What do these kind of advancements in material sciences and AI helping us figure out material sciences? What does that bring us for the future of materials?
The thing that's going on here, it's super cool, and in some ways it's relatively straightforward. What you're doing is taking a catalyst and a adsorbate that and trying to find the correct configuration, or as they call them, relaxations, iterating over relaxations until you find the sort of minimal energy state of the system, which should provide you the most stable configuration of the system that in the real world is actually stable and usable. So, it's doing this stuff at a rate that's far faster than you could obviously sit there and calculate and simulate one at a time. Like the folks at, I think, OpenCatalyst is, if I remember it was correctly what it's called, said, you should check this stuff out against the real world. This thing is just going to, potentially give you some directions to try out. But you'll have to test it against a real world situation to see if that's actually a stable state. You're trying to get to a stable state of, catalyst meets adsorbate.
Yep. Very exciting model though, because of course, as you said, you have to test it physically in the end, but instead of testing every single one physically, you see the angle you want to go for, test that physically, and then maybe make tweaks in the physical world from there.
Elon himself chimed in on these tweets and said, this is really interesting, or has strong potential, or something to that effect. So, he's definitely thinking and dealing with this stuff with just about every startup he has.
Well, maybe Elon does like some stuff Meta makes them.
Yeah.
And next up, we have Google's DeepMind's R2 speaking robot. It's a first of its kind vision language action model. So of course it's trained mostly on web images and web text, like most of these image and text models, and then also trained a little bit on actual robotic actions. So then it can look at the real world, you can give it directions, it can see what's in its environment, and then it can act in new ways that it was not trained on. You can tell it, hey, pick up this trash and throw it away, even if it's never picked up trash before, even if it has never been told to throw away trash before. It can use its knowledge of the web, use its knowledge of images and text, and use its knowledge of how to move its own arm and follow those directions very well. So it's very similar to what we've seen so far in complex engineering stacks of multiple models being used together to achieve these results. But now it's a single model that is integrated and is a foundation model for robotic actions. So Ethan, we've talked a lot about how there's engineering hacks and then final outputs of real foundational models. How does that make a difference here?
Yeah, this one's actually a complete model trained on it. They had a good description saying hey, some of the other alternatives and way people are approaching it is pretty much as if you had to think of something in your mind and then go describe to your body how to do it. It doesn't have that natural flow, right? So them combining it all into a single multimodal model is fascinating. In the DeepMind article here, the coolest part I saw was they have a cable and a rock and a piece of paper on a table. And they say, hey, I need to hammer a nail. Which object from the scene is most useful? And it picks up the rock. So this kind of chain of thought reasoning they've embedded into it, as well as the entire like multimodal foundation model itself, enables these things that are, were super hard before, but are kind of common sense to people to do, which is, hey, a rock's probably going to hammer a nail, or this object is probably best for this use case. So we're leaving the era of having a program, grab that rock, hit this nail, and here's your task, and to these actual robots that can reason. And I'm super pumped. This is honestly, I think, the best application of it I've seen so far, better than some of the engineering piece togethers.
Farb, what do you think of this?
Yeah, I think this is the first big step in a new direction here. They built a single model, I think they call it VLA, vision language action. They've tokenized the actions, sort of moving from the vision language model world to the vision language action world. This is probably sort of a seminal move here in the space. I think they said they found something to the effect of about 90% accuracy in simulations, which is pretty crazy. Probably not something you want on a factory floor or in a nuclear reactor, but it's a huge step forward from a lot of the other things. And I think it's twice as good or so, compared to their previous version.
I think it was 30% to 60%. So yeah,
60%. Yeah. Huge leap there. It's, you look at all their examples and you can just see how this can intuitively work. So, some of these things, someone have to cross that barrier. Like, okay, this thing just kind of makes sense. If it's trying to mimic human behavior, it seems seems likely that it should make some intuitive sense to humans that are taking a look at it. And it sort of passes that sniff test. I thought it was a huge paper, and they took it pretty seriously. They made a great couple of blogs describing it all with great animations, and super impressive to see.
Yeah, they put a lot of great story into it of why it's important. And as you just said, like how the thinking of it is more similar to how a human thinks and why that's important. So definitely recommend reading it. And then lastly today, we have Adversarial Prompts. A team at Carnegie and a few other universities work together to make LLaMA 2 generate adversarial prompts that work against chatgpt, that work against Bard, that work against Claude. Farb, you do a lot of prompting. What do you think about this?
This is concerning to say the least. Yeah, I mean, the prompt, injections, the suffixes that they showed in their paper, OpenAI has already plugged those up. Yep. But there's a whole bunch of other ones that aren't in the paper. They're probably trying to recreate this paper at OpenAI and every other place so that they can figure out what holes to plug up. It's almost, this is a pretty serious hole I think they found here, and it's not going to necessarily be easy to stop it, and it might be easy to replicate it. So
I believe the code's actually open source. So I think people are already out there using the code to generate suffixes that weren't in the paper and then use those to make the same attacks.
This is classic arms race stuff. So I don't know. We're gonna have to keep our eyes on this one. This is not the best news.
It does technically violate the terms of service of LLaMA, because LLaMA terms of service says you can't use it to improve other models, which technically this is what it's doing.
Tell that to some nefarious state actors. I'm sure they're super concerned about the TOS. I'm sure the guy trying to, do shady stuff in his cave is really concerned about the lawyers coming at him on his TOS violation. This is, that stuff is irrelevant to anybody who was going to do something nefarious with this. Anyways, I'd be lying if I thought if I was saying this was good news. This is bad news. This is a major problem and it needs to get fixed.
Tony Stark built adversarial prompts in a cave.
Yeah, likely.
Ethan, any thoughts?
I just think it's cool that these are not, it's not like, hey, we broke llama, right? It's like, hey, every single transformer based one we've tried, GPT-4, ChatGPT, Claude, llama, like they're all the same. And these adversarial suffixes work. And we don't have to go manually make prompts and test them ourselves. Like there's a formula to how to break these things. So yeah, we'll see if it gets plugged. It will. And then it's kind of like cybersecurity. It's an endless game of whack-a-mole.
It's an arms race between both sides. And I think these folks probably did the right thing about being transparent about it.
There's a lot of examples of like individual tokens from like weird Reddit users that can break every single model, and this is very similar because of course all these models are essentially all trained on Common Crawl. So some weird tokens from Common Crawl combined together, you break your prompts.
This is the classic: take something someone on take something someone on Reddit is doing and scale it.
Yeah. Well, those are our 3 stories today. Crazy as always. What have you guys been seeing? Farb?
I saw something earlier, but I forgot what it is, so I'm just gonna skip for today. Spare you people.
Ethan?
I've been doing some advising for AI on like public health. And I think, we always speak about this on different episodes, but the speed at which enterprises and even governments are bringing AI into the fold is fascinating. They've thrown together a rapid group and actually putting together pilots out there and actually trying to fix some of these workforce issues. And, a cloud computing or mobile wave took them 10 years to try to implement. They're actually moving really fast on this. So just exciting to see kind of state of the world.
Well, to match your exciting news, I bring 11 Labs having new voices.
Nice.
Yeah, I saw that. That's so cool.
Yeah. Some ASMR stuff, some audiobook stuff, some video game stuff. So if you're waiting to publish your ASMR novels, 11 Labs has got you now.
To add to that, I think I saw a Martin Shkreli tweet where he was talking about training on large corpus of natural speech to try and make something better than TTS. Not entirely. He also posted a picture of him like the self in the New York subway train. I don't know what he was doing here, but that was semi interesting.
Well, wonderful as always. Thank you guys for tuning in. We will see everyone next week.
See you guys.